Okay, so here we are at chapter 9, section 1 again. Last time we covered the first few sections, and now I'm going to be starting with applying the distributive property and working on the rest of these topics. Okay, so for this next problem that we're going to work on, we're continuing on section 9.1 from where we left off in example 4. So first read the math and context up above. So pause the video and read what a unicorn company is. But we're going to look at the example 4 says the number of unicorn companies worth $1 billion or more can be modeled after this equation right here. So that's the equation we're going to need. So I'm going to go ahead and write it down below. N equals 3.625x plus 42. And x has to be between 0 and 20. And it's the number of months after January 2014. If it's more than 20 months, the equation doesn't work. So use this equation to determine the x value. So we're going to determine the x value. So this is what we're finding. So I'm going to underline x, or you can circle it or something to say that's what we're finding. When n was equal to 100, there were 100 unicorn companies. So we're going to set this equal to 100 because that's what n is. Or you can come down below here and write 100 equals and do it that way. It doesn't matter. All right, so we're going to solve for x, which means first we have to do addition and subtraction since there's no parentheses on this one. And we get the 42 subtract out, and we get 3.625x equals 58. All right, so remember we don't subtract 3.625. We divide it because they are multiplied together. It's a coefficient. So we're going to divide both sides by 3.625. And you're going to get x equals, put that in your calculator, and you're going to get 16. So don't stop there, because what does this actually mean? So 16 means 16 months after January 2014. So 16 months after January 2014. So when was that exactly? When was January 2014? So you might need to count on your fingers, or whatever you need to do is fine. But think through it, and January 2014 to 2015 would be 1 year, that's 12 months, and then 4 more months after that. So you should get that this is May of 2015. Okay, so now I've got one for you to try. So this one is about internet users, the number of internet users, and an equation. So give this a read. Make sure you read through it carefully and write down the things you need to know. Pause the video and give it a try. Okay, so there's a few things here that you need to make note of. I is in millions, so you don't have to put million into the problem. So it's in millions already. During the year X, X has to be greater than 2007. So if you get a number less than 2007, something didn't work. Here's our equation, so you want to write down the equation. And you're going to put 1730 in for I. Rearrange to solve for X, and you should get 2009.004149, and that doesn't really matter because it's either way, it's the year 2009. Okay, next we're going to look at solving linear equations applying the distributive property. So what it says right here is that we need to use the distributive property first. So always use that first and then rearrange. So this first one right here on A is we're going to distribute the 4, and we get 4x minus 4 times minus 3 is 12, plus x is 0. So we're going to combine the two x's, and you can highlight or you can underline, but I do recommend kind of going through and finding all the like terms and doing something similar with them when the equations get complicated. So we get 5x minus 12 equals 0. We're going to add 12 to both sides, and now's the time for the for using the addition property. And you get 5x equals 12. Give myself a little more space here. Now 5 is multiplied times x, so what are you going to do to make the 5 go to the other side? You're going to have to divide by the 5, because it's not added, it's multiplied. And that means x equals 12 fifths. Okay, so that's the answer to that one. So the next one is off to the right here. All right, we were supposed to check the answer for part A. So you need to put 12/5 in for x. So we will go ahead and do that. So we've got, I'm going to do this in a different color so you can see that I'm checking. So we've got 4 times 12/5 minus -3 plus 12/5 equals 0. All right, so that's a little bit of a mess, but we've got, let's see, we've got 48/5 minus 12 plus 12/5. Does that equal 0? Well, we don't know yet. So I'm going to combine the two fractions and we get 60/5, and I'm going to turn 12 into a fraction of fifths. So I'm going to take this times 5/5, and I get 60/5. So does 60/5 minus 60/5 equal 0? Yes, it does. So that one checks. Okay, so I'm going to do B, and I'll come over here to the side to do that. All right, so we've got 2 times 3z minus 4 plus 1 equals, now we have another distribution on the other side, 3 times z plus 1. So we have to distribute all of these through the problem. Okay, so we're going to distribute the 2 first. We get 6z minus 8 plus 1. So the 1 is out there by itself, so it doesn't have anything multiplied by it. And then 3z plus 3. Now we need to put everything together. So I'm going to subtract the 3z. By that I mean put like terms together. So 6z minus 3z is 3z. Minus 8 plus 1, so I'm going to combine these two because they're like terms. So negative 8 plus 1 is minus 7, and that equals, on the right side, all I have left is 3. So now this has become a much simpler problem. I'm going to add 7 to both sides, and I get 3z equals 10. Divide both sides by 3, and I get z equals 10/3. Okay, so that's the final answer on that one. If you want to check it, you can. I'm going to go on. Okay, now there's one for you to try. These are similar to the ones I just did. You need to check your answer for part A. So practice checking your answer. Pause the video and give it a try. Okay, so here's the answers. I highlighted where the x's combine up here on the same side. And I probably should have done that here as well, because those combine to be 0. Actually, you subtract 2 and you get a negative 2. But don't forget on A that you were supposed to check, so I put in blue where you should replace the x with a negative 1/2. And take a look and make sure you've got those all right. So the next topic is about solving linear equations by clearing the fractions and the decimals. And so some of this is a review, but this is to make this just a lot easier, so you don't have to deal with fractions or decimals. So we're going to clear fractions and decimals by multiplying by the least common denominator. And if you don't choose the least, if you just find a common denominator, it actually still works. So decimals, remember, are a form of a fraction, so they are also the least common denominator, but basically you're going to choose the one that has the tiniest number, the one that has the decimal going to the farthest place to the right. So remember that this is tenths, hundredths, thousandths. So if you have 1 to the thousandths, you're going to multiply everything by 1,000. We'll look at some of these. All right, so we're going to solve this first one by multiplying everything by the least common denominator. And if you take a moment to stare at A, you'll see that everything has a 7 in the bottom, so that's pretty straightforward. So we're going to multiply every single thing by 7. So I'm multiplying both sides by 7, or 7/1, however you want to think of that. So the first one is going to be 7 times 1/7, and that becomes 1/7 times 7/1, x minus 7 over 1, and you don't have to take this long step here, but I just want to show you at least once what this looks like. So every single thing gets multiplied by 7 over 1, and I put it over 1 so that it was more obvious what's going on here. So the 7's cancel in every case. Okay, so we end up with, on the first one, we just end up with x minus 5 equals 3. So now it's very simple. We're going to add 5 to both sides, and we get x equals 8. All right, so that suddenly became very simple without the fractions. All right, the next one we're going to look at is 2/3 x minus 1/6 equals x. So what is the least common denominator there? And that one is 6. So times 6 and times 6. So we get 6 over 1 times 2/3 x minus 6 over 1 times 1/6 equals 6 times x is just 6x. Alright, so let's look at what happens to these. So 6, remember, is 2 times 3. So the 3's are going to cancel out, and we are left with 2 times 2. This is why we worked on fractions so much before we got here, because this is pretty important to be able to do. 4x minus, everything cancels here, and we just get minus 1 equals 6x. Okay, so I'm going to add 1 to both sides. And then I'm going to, so I get 4 equals 6x minus, or plus 1. And I'm going to subtract, 4x. I'm going to subtract, running out of room, so give me just a moment here and I will add some more room. So now we're going to subtract 6x from both sides, and I get negative 2x equals 1. Divide both sides by negative 2. And you end up with negative 1/2 on the right. So x equals negative 1/2. Okay. So now it's time for you to give it a try. So you try these and see if you can get the right answer, and come back and check. So on the first one, you should get 2. Multiply both sides by 4. Be careful with all the steps, and you cancel things properly. And on the next one, so pause these and stare at them if you need to, or rewind and take a look. The least common denominator is 12. So you're going to multiply every single thing by 12, and canceling here is something from a few chapters back, so make sure you know how to do that. So first I broke 12 into 3 times 4 so you could see what canceled. And you should get 8/3. Okay, so example 7, we are going to solve linear equations that have decimals in them. So I've rewritten the first one so that we can have a little bit more room. So think about what is the least common denominator. Each of these goes to the tenths. So you want to go to the one that goes the farthest to the right, and they all go to the tenths. So we're going to multiply every single thing by 10. Okay, so multiply 10 on both sides. So 10 times the first one, 10 times the second one, and 10 times the last one. Make sure you get every term. Now remember, when you multiply by 10, you moved one place to the right. So this one becomes 2x minus this one becomes 7, and the right one becomes 4. And it suddenly is a much simpler equation. So we're going to add 7 to both sides, and we get 2x equals 11. So x, sorry, I'll back up. Taking it a little too fast. I'm going to divide by 2. And we get x equals 11 halves. All right, let's try the one on the right, the b, and I'll put it on the right, is what I'm trying to say. All right, so we've got 0.01x minus 0.42 equals negative 0.2x. And I want you to think about, what is the farthest to the right that any of those go? And it would be both of these right here. Both of those. That was ugly. I'll get rid of that. So we just want to multiply everything by what? Think about what we're going to multiply everything by. And it's 100ths place, so we're going to multiply everything by 100. So every single term on both sides. That way we haven't changed the value of the equation at all because we've multiplied everything by the same thing. Okay, so the first one is going to become, move it 2 places to the right, and it becomes 1x, or just x, minus 0.42 times 100 is 42, equals negative, don't forget the negative. Now we've got to move it 2 places to the right. So if we've got 0.2 and we move 2 places to the right, we're going to have to put that 0 in there. So it becomes 20x, negative 20x. So let's add 20x to both sides, and we get 21x minus 42 equals 0. So we'll add 42 to both sides, and we get 21x equals 42, divide by 21, and you get x equals 2. You can go check and make sure you think that's right. But now you have a chance to try it yourself. So why don't you give these 2 a shot after you pause the video and come back and see if it's right. Okay, here are the next 2 for you that you were supposed to try. So the first one, you have to multiply everything by 10, and you end up with 1.75 or 7/4. But normally when we have a decimal problem, we can answer with a decimal. The bottom one, you want to multiply everything times 100, and you should get x equals 3. Okay, I want to just talk to you a little bit about identifying equations with no solutions, one solution, or infinitely many solutions. And I've got all 3 examples here. And I just want you to take a look at these and think about how they could possibly happen, and if they are possible. So x plus 5 equals x. So I just want you to think about this. Is there any number you could think of that you could add 5 to it and still get the same number? So I've got a number here. I'm adding 5, and I get the same number out. It's not possible. So if you think about it algebraically, though, you could subtract x from both sides, and you get 5 equals 0. Is that true? No, it's not true. That is not a true statement. Okay, I'm having a little internet lag here, so if it continues, I'll try something else. The next one, we've got 4x minus 1 equals 7. Well, it looks like a linear equation, so I'm going to add 1 to both sides, and I get the 1's canceling out, and I get 4x equals 8, so x equals 2. That is a true statement, so that has one solution. All right, the next one. So we're just going to stare at this one for a second since I've got my internet lagging right now. We've got 5x equals 2x plus 3x. So we get 5x equals 5x. So think about what x's are going to make that true. Well, every x. I could plug in a 1, a 2, a 3, a 4, a 5. I could plug in negative numbers. They're all going to make it true. So this is always true. So we're going to look at what all of this means. Okay, so we've got a little grid here. We are going to look at the ones with no solutions, the one with one solution, and the one with infinite solutions, one at a time. So the first one we looked at had no solution because it turned out to be 5 equals 0, which is not true. So if we wrote this in ax plus b equals 0 form, we would get 0x plus 5 equals 0. The simplified form was just 5 equals 0, like we had before. This is always false. Always false. This is called a contradiction. Okay? So it's a contradiction, it's always false. If it has one solution, we can rewrite this as 4x minus 8 equals 0. So I just subtracted 7 from both sides. And we would say a is 4 and b is negative 8. The solution was that x equaled 2. That was up above. When is it true? It's true for exactly one number. Exactly one number. And this is called a conditional equation. Okay, the last one, that one just has one solution. The last one, it has infinite solutions, and if we rearranged this, we would get 0x plus 0 equals 0. And if we simplified it, we would just get 0 equals 0. So when is this true? It is always true for everything, no matter what. Always true. So this is actually called an identity. And it has infinite solutions. Okay? So if this is the situation, we have infinite solutions. If there's only one solution, well, there's only one solution. And there are some that have no solutions. So we're going to look at some examples of these. So as usual, I'm going to give you 3, and you're going to try 3. So I'll show you these, and we're supposed to determine whether they have no, one, or infinite solutions. All right, so the first thing we need to do is distribute the 2 across the parentheses. So we get 3x equals 2x plus 2 plus x. So we get 3x equals 3x, so I'm combining these two x's right here, plus 2. Well, is that ever true? I'm going to subtract the 3 x's from both sides just to show you. I get 0 equals 2. This is never true. This is false. False. So there's no solution to this. There's no number we could put in to make that true. All right. The next one, we're going to do the same thing, distribute. So we've got 2x minus 1, so distribute the negative, equals x minus 1. Okay, so 2x minus x is x minus 1 equals x minus 1. Well, when is this true? It's pretty much always true. So if we subtracted everything from both sides, we'd end up with 0 equals 0. So this is true, always true. So this has infinite solutions. Infinite solutions. Okay, the last one is 5x equals 2x minus 8. Subtract 2x from both sides. And we get 3x equals 8, divide by 3, and we get x equals 8/3. There is one solution to that, and we just have to show what it is. Alright, so now it's time for you to give these a shot. So try these and come back and take a look at the answer. Alright, so this first one, hopefully you looked at it and noticed that there's no way that you could have 5x plus 1 equal to 5x. So you can also subtract 5x from both sides to get 0 equals 1, so there's no solution. B, you find that x equals 0, so there's one solution, x equals 0. And C, there are infinite solutions because you end up with 0 equals 0. Or two sides equal to each other. That means you could plug anything in and make it true. The next topic is solving a formula for a variable, because sometimes it's easier to rearrange a formula first before plugging in the values, because the values might be big, long, messy things. So it's easier to just rearrange first. So the first thing we're being asked to do, this is an area of a trapezoid. We're being asked to solve for B. Okay, we're going to solve for B. So we've got A, let's see, I think we'll do this a little darker. A equals 1/2 A plus B times H, and we are supposed to solve for B. I highly recommend underlining, circling, highlighting the one you're supposed to find, because sometimes you kind of get lost in it. So the first thing you can do is divide by H on both sides. So we're just going to divide everything by H, and I get A over H equals 1/2 A plus B. Think of this as kind of peeling an onion, trying to work our way into the inside. So now we're going to multiply everything. I'm going to use different colors so you can see what I'm doing. Multiply everything by 2 over 1, and I get 2A over H equals, I don't need the parentheses anymore actually, because it's not multiplied by anything anymore, so you don't need them anymore. And now we're going to solve for B, so you might want to keep highlighting all the way through just to keep track. I'm going to subtract A, and I get B, the thing that we highlighted, equals 2A over H minus little a. Okay, had a little bit of lagging once again, so b should be 2 big A over h minus little a. So that's our final formula. So why don't you try this for solving for h in the formula volume equals 1/3 pi r squared h. Okay, so here's how you solve for h. I tried to put the work that I did rearranging in pink so you could see what I did. All right, so there was a second half of this problem, and I'm going to do it now. So coming back up here, the second half of the question asks, the trapezoid has an area of 36, a height of 4, and a base of a equals 8. So we're just going to plug everything in. Now we're going to find b. So it's asking us to find b, which we just solved for. So we're just going to use the formula here that we already found. B equals 2 times the area over the height minus the base a. So we've got 2 times 36 over 4 minus 8. So 2 times 36 is 72 divided by 4 minus 8. 72 divided by 4 is 18 minus 8 is 10. So a equals 10, let's see, what was it, inches, 10 inches. Okay, this is the very last example. We're rearranging equations to solve for a variable in kind of more complicated equations. So this next one, we want to highlight what we're looking for. So highlight that and make sure you see what you're doing there. So the first thing we're going to have to do is multiply both sides by 2. So we get 2c equals a plus b. And we're still looking for b, so we're going to subtract a from both sides, and I get b equals, notice I just switched sides and that's fine, 2c minus a. As long as you can keep track of it all in one step, it's totally fine. So we're going to say b equals 2c minus a. Recording while having a lag is very interesting. All right, so this next one is we are looking for c, and we've got 2 of them. So this one has a little different technique. We want to get them both to the same side. Okay, so I'm going to add, we don't care which side, so try to, if you're hung up on having the thing you're looking for on the left, you need to try to work on getting over that, because it doesn't matter if it's on the right or the left, it just matters if it's by itself. All right, so we've got BC, and we just subtracted it out, and so now we're left with AB equals AC plus BC. Well, since we're looking for C, so we're looking for this and it's in both of them, we can factor it out. So this is the hardest part for most people. We're going to factor out the C, and we're left with A plus B. It doesn't matter if it's first or last, it's just factored out. All right, so now we're looking for C. We want it to be alone, and the only way to get it alone now is to divide by the quantity A plus B. By the quantity A plus B. And so now we get C equals AB over A plus B. And that's the final answer for C. All right, so there's going to be a few here for you, just a couple for you to try, and that'll be the end of this video. So let's move down and take a look at some for you to try. So pause the video and give it a shot. So the first step on the first one to solve for B is to multiply both sides by 2. And then there's no fraction anymore, and then to subtract A and C from both sides. And you get 2s minus A minus C equals B. The last one, you want to isolate the A, so you want to get them both on the same side first, and then factor out the A, and then divide by B minus D on both sides, and you get A equals CD over B minus D. And that is the end of this video. It was a long one. Thanks for sticking it out to the end.